Good morning, everyone. I'm Aiswarya, Assistant Professor in the Department of EC, working at Emmanuel JJ College of Engineering. Today, we are gonna see a new topic: Superheterodyne Receiver. Let's go inside the section. Actually, superheterodyne receiver is nothing but it converts all the incoming RF, that is radio frequency signal, to fixed lower frequency signals. So that converts the signals, that converted signal, that RF signal is converted into a lower frequency signal, and that lower frequency signal is called as immediate frequency signals. Okay, that lower frequency signals is called as immediate. See, that is called as immediate frequency signals. This immediate frequency, these IF signals is so these immediate frequency, I'm sorry, these immediate frequency signals is amplified and then detected to get the original signals. Okay, so these are amplified and then get detected. These are called as super heterodyne receivers. So this is the block diagram for super heterodyne receivers. Okay, so this is the antenna, the signal from the antenna, that is the incoming signal that is given to the RF stage, in which the RF amplifier, this RF stage means that RF amplifier which amplifies the signal which is given from the antenna. So again, the RF signal amplifies all the signals in the required range of frequency. So what range of frequency is needed inside the receiver that amplifies the incoming signal to that required frequency? Again, the mixer and the local oscillator. The mixer, that is the output from the RF amplifier is given to the mixer, and then the output of the local oscillator is also given to the mixer. Let us assume the output from the RF amplifier is Fs and the local amplifier is F0. So they two get mixed inside the mixer, and so the output may be F0 minus Fs. See, this one, F0 minus Fs. So this is called as the immediate frequency signal. That is the output of the mixer which is given to the IF amplifier, that is the immediate frequency amplifier. So the signal in the IF has same modulation as in the input signal. So again, in this IF amplifier, what we are doing is the IF signal is amplified by one or more IF amplifiers. Okay, more than one or two amplifiers will get, and then it is given to the signal is given to the detector section. So normally the IF signal is fixed for an AM receiver. Okay, this is an AM super heterodyne receiver. So the input signals for this IF amplifier is always fixed. So the if you want to change the frequency for the F0 from the local oscillator, then you must have changed the frequency from the mixer also, that is Fs also should be changed, so that the bandwidth will get narrow. Okay, again, this AGC, what is this? AGC is automatic gain control. It is a part of a output is taken from the detector. Okay, some part, the output, the detector has many the detector has output, and only a little part of the output from the detector is taken taken by this AGF, that AGC, that is automatic gain control. So, and again, it is the part of output is taken from the detector and is applied to the RF amplifier, mixer, and then IF amplifier. You can see through this block diagram, see, something is given to IF amplifier, a little part is given to the mixer, and a little part is given to the RF amplifier, so that it can maintain the constant output voltage level. By doing this, it can get the constant output level. Again, the detector, it converts AM signal. The detector converts the AM signal to the original modulating signal. So diode detector is mostly used. Okay, what type of detector is used in super heterodyne receiver is diode detector. So the output of detector is low power audio signal. Okay, the output of the detector is a low power audio signal, so that it is given to the audio and power amplifier, in which the signal from the detector is a low power, that is a weak signal, hence it gets amplified in the audio and power amplifier. It has one or more stages, as I said, in the detector. So the signal is also amplified and then again given to the speaker. This one is the speaker. Okay, so first the incoming signal is taken from the antenna and is given to the RF amplifier for amplification. Then the output may be Fs, which is given to the mixer, and the output from the local oscillator F0 considered, that is also given to the mixer. That gets inside the mixer. Then it is given as a difference of F0 minus Ff to the IF amplifier, in which it gets intermediate frequency amplification. So again, again, if you need to change the F0, you have to change the FS also, so that the bandwidth will be getting in a narrow method. Again, the output from the IF amplifier is given to the detector. There is a diode detector is used here. The output from the detector is low frequencies, so a little amount is taken by the AGC, that is automatic gain control, to IF amplifier, mixer and RF stage, so RF amplifier, so that it can maintain the constant output voltage. So the output from the detector is so weak, so that it should be get amplified using the audio and power amplifier. So it gets amplified there, and it is given to the signal is given to the speaker. Okay. Again, components, there is the antenna, RF, that's what I explained in the block diagram. Applications, they are used as AM and FM radios and televisions, radar systems and communication receivers. Advantages are they have stable performance, easy to tuning, and wide frequency coverage can be used, and this design is simple. Okay, so these are the advantages of super heterodyne receiver. So if you have any doubts, please mention it in the comment. Thank you.